Welcome everyone. Let's learn how to differentiate with the help of ln. We want to differentiate a to the x with the help of ln. If you want to differentiate a to the x, we need to realize something. Our power is a variable here. We did not differentiate something like this until now. Therefore, it's time to learn a new method to differentiate when our power is a variable. We will add ln to both sides. ln y will be equal to ln a to the x. I know a property of ln. If I have ln a to the power of b, this will be equal to b multiplied with ln a. You can send b to the front as a constant. Let's use this property. From here, this will be equal to x multiplied with ln a. We are differentiating with respect to x. Therefore, if we differentiate ln y, derivative of inside of it, y derivative, over inside of it, y, is equal to ln a is a constant here. We will differentiate x, which is equal to 1 ln a. I want to figure out what y derivative is. Send the y to the other side, multiplying both sides with y. Y derivative is y ln a. My y is a to the x. So therefore, y derivative is a to the x ln a. If you let a to be e specifically, you will see derivative of e to the x is equal to e. Example, y is equal to e sine x e to the sine x cubed. What is dy over dx? Another notation for differentiating with respect to x. Let's start. We are differentiating e. Therefore, we will use the rule. What is my rule to differentiate e? First, I write the function e to the sine x cubed, and then I multiply it with the derivative of the power. So we need to differentiate sine x cubed. What is the derivative of sine x cubed? This is a composite function. I start with differentiating from outside, cosine x cubed, and then I multiply this with the derivative of inside, 3x squared. I multiply this with the function cosine x cubed. Let's put the 3 here, multiplied with x squared. This is my derivative. Logarithmic differentiating. We want to differentiate y is equal to f of x to the power of g of x. To evaluate this, we need to add ln to both sides. And again, from the properties of ln, you can write this as gx multiplied with ln fx is equal to ln y. When you differentiate respect to x, you will see ln y's derivative is y derivative over y. You will send the y to the other side, multiplying both sides with it, and you will get the derivative. Y is equal to x to the sine x, and find what y derivative is. There's a function, and it's to the power of another function. Therefore, we need to use the help of ln. ln y is equal to ln x to the power of sine x. From here, ln y is equal to sine x multiplied with ln x. Derivative of left side is really simple. Y derivative over y. Now we need to differentiate ln x multiplied with sine x. This is derivative of multiplication, derivative of first term 1 over x multiplied with the second term, sine x plus derivative of second term, cosine x multiplied with the first term. So this is equal to sine x over x plus cosine x multiplied with ln x. Next step is sending the y to the other side, multiplying both sides with y. Y derivative is equal to, what is my y? X to the power of sine x. Y derivative is x to the sine x multiplied with sine x over x plus cosine x multiplied with ln x. Y is given to us to the power of x cubed. Evaluate y derivative. Again, I cannot differentiate it like this. I need the help of ln. ln y is equal to ln q to the power of x cubed. We can write this as ln y is equal to x cubed ln2. ln2 is a constant, so I don't need to differentiate according to the multiplication. I just need to differentiate x cubed. Derivative of ln y, we are differentiating respect to x, so y derivative over y is equal to x 3x squared ln 2 to multiply every side with y. What is y? 2 to the power of x cubed. Y derivative is equal to 2 to the power of x cubed multiplied with 3x squared ln 2. In this problem, there's a function given to us and it's asking derivative of it. You might ask, what is this problem doing in this video? Because clearly you can differentiate this according to multiplication and division. But the point is, if you try to do that, it would take too long. So instead, in problems like this, use the logarithmic property, which is ln a multiplied b can be written as ln a plus ln b, and ln a over b can be written as ln a minus ln b. Now, add ln to both sides. ln y is equal to ln x squared plus 1 cubed root e to the x over x minus 2 to the fourth power multiplied with cosine x. ln y is equal to, I'm using the properties, ln x squared plus 1 cubed multiplied with root e to the x minus ln x minus 2 to the fourth power multiplied with cosine x. ln y is equal to, now using the property again, ln x squared plus 1 to the third power multiply plus ln root e to the x minus ln x minus 2 to the fourth power plus ln cosine x. You might say this is still taking too long, but I am going step by step just to show every property. You can skip some of these properties faster. From here, ln y will be equal to 3 ln x squared plus 1 plus e to the x can be written as e to the x 1 over 2, send 1 over 2 to the front, ln e to the x, ln e to the x. You can send the x as well, and ln e is equal to 1. Therefore, this part is x over 2 minus 4 ln x minus 2 plus ln cosine x. Start differentiating. Y derivative over y is equal to 3. Differentiate inside of this, multiply. Differentiate inside of this 2x, this is over x squared plus 1, plus differentiate x over 2, 1 over 2, minus 4, differentiate inside of this 1, this is over x minus 2, plus differentiate inside of this negative sine x, so therefore this is minus sine x over inside of this cosine x. From here, y derivative is equal to multiply both sides with y. I'm just gonna copy paste this. Copy paste it here. Perfect. Like this. This multiplied. Let's copy paste 2. I did not take some parts, I think, but let me see. Wide width. Well, I did not take 3. So this is my y derivative, and you will leave it like this. If you see a problem like this in an exam, I want you to differentiate multiplication and division of a lot of terms, it probably wants you to use ln because it makes things faster like this. And no one will ask you to do this algebra or simplify this. You can just leave it like that.